All right, guys. So our next lesson is on one more method of how to solve a quadratic equation. So if you run into a situation where you can't solve a quadratic equation by factoring and you can't just solve by taking square roots, it may be a good candidate for the completing the square method. So the way that completing the square works is we use what we know about factoring and we use what we know about taking the square roots, and we kind of combine those two methods to put it into a way that we can solve any quadratic equation. So here's how it works. We'll start off with this basic equation that we know how to solve because we can take square roots to solve it. X plus 5 quantity squared equals 100. We can take the square root of both sides, and then we'll get x plus 5 on one side. And then remember, 100 has two square roots, positive 10 and negative 10. So x plus 5 could equal 10, and x plus 5 could equal negative 10. And so therefore x is equal to 5, or x is equal to negative 15. Okay, two solutions to that equation. Now we'll come down to this one. So this equation is not written in such a way we can do the square root method. And this side is not set equal to 0, so it doesn't look like it's factorable right off the bat. But if we kind of think about it a little bit further, we might see that we can actually do something with this. So up here, we had a perfect square, a binomial squared, and we were able to do it with the square root method. This is a trinomial, but I think that I can factor this one, and I believe it's a perfect square trinomial. I think so because this last number is 3 squared, and the middle number, well, it's negative 3 doubled, and this is negative 3 squared. So if you can find some number such that you double it and you get this, and you square it and you get this, you have a perfect square trinomial. Therefore, this side of the equation factors, and it factors to x minus 3 quantity squared equals 49. And now we have an equation that we can solve by square rooting. So we factored this side since it was a perfect square trinomial, and once you factor it as a perfect square, you can square root both sides. This is at the heart of the completing the square method. So then we'll square root both sides. X minus 3 equals 7, and x, or it can't be both at once, it's not Schrodinger's x. X minus 3 equals negative 7. So x could be 10, or x could be negative 4. Okay, so two solutions to that one. So completing the square means you manipulate the equation so that you turn it into a perfect square trinomial even if it's not. So in this situation here, x squared plus 8x plus 10, that's not a perfect square trinomial because there isn't any number such that I can double it to get 8 and square it to get 10. However, I could make it a perfect square trinomial. It's not that far off. 8 is 4 doubled, and 16 is 4 squared. So if I can turn this into a 16 instead of a 10, it would be a perfect square trinomial. Of course, if I'm changing the value on one side of the equation, I have to change the value on the other side of the equation. So this is my way of completing the square. I take the constant on this side and I get rid of it completely, and I'm going to get rid of it on this side too. So that gives me x squared plus 8x equals 20. So it just kind of gives me this blank spot here where I'm going to add the number that will make this a perfect square trinomial. So since this is 8x, I'll take the 8, cut it in half, that's 4, and square it, that's 16. I'll add 16 to both sides, and then plus 16. Now that I've done that, I've successfully changed the equation so that this is a perfect square trinomial. This is x plus 4 quantity squared. Okay, and then the other side is 20 plus 16, that's 36. And now I have an equation that I can solve by taking the square root. So I'll do x plus 4 squared, and I'll square root it. That will be x plus 4. And then 36 has two square roots, positive 6, and or x plus 4 is negative 6. So therefore x is equal to 2, or x is equal to -10. So 2 solutions to that equation, and we solved it by completing the square. So we'll move on to this one here, and this time I'll be explicit about what the steps are for solving it. So the first thing I do is I subtract the constant from the side that has all the x's. So subtract the constant from both sides. Okay, so in this case, it's the 15. So I'm going to do subtract 15, and on the other side, I'm going to do subtract 15. And that gets me x squared plus 12x, I'm going to leave a gap because I'll add something to it in a bit, equals 79 minus 15, which is 64. Okay, perfect. So next, I'm going to add whatever is needed here to make this a perfect square trinomial. So part 2, you find the term that just has the x, cut it in half, square that, and add it on. The method that I'm teaching you only works if there's no multiplier in front of the x squared. We'll cover that possibly in a future session, but so this is just very beginning completing the square. Okay, so that leaves us with x squared plus 12x. So to find what I'd add on here, I take the 12, cut it in half, that's 6, square it, I get 36, and I'm going to add that on, plus 36 equals 64 plus 36 is 100. Okay, step 3. I'm going to rewrite this side of the equation in factored form as a perfect square. So in factored form, that would be x plus 6 quantity squared. Okay, and then lastly, we're at a place we're ready to solve it. Take the square root of both sides. So you square root both sides, and you may have to solve 2 equations, the positive and the negative. So it would be x plus 6 equals -10, and then x plus 6 equals 10. So therefore, x equals -16, or x equals 4. So those are our 2 solutions to that equation. So there's the steps kind of written more explicitly. Let's try this one, this time just going through the steps, but I won't write them down explicitly. We'll just try to remember what they are. So first of all, I'm going to take this 60 and I'm going to get rid of it from both sides. Now initially I said subtract, but of course this is already subtracted, so I'm going to add it. So we'll do plus 60 and then plus 60. Okay, then it leaves us with x squared minus 18x equals 319. Okay, next we're going to take that -18, cut it in half, and square it, and add that on. -18 cut in half is -9. -9 squared is positive 81. We're going to add 81 to both sides. Plus 81, and then plus 81. So that gives us x squared minus 18x plus 81 equals 319 plus 81, which is 400. Okay, then we can rewrite this in factored form. Since -9 is what you get when you cut this in half, and -9 times -9 is 81, the factored form of this is x minus 9 quantity squared equals 400. And then you square root both sides to solve it. The square root of x minus 9 squared is x minus 9, and 400's square root could be -20 or positive 20. So therefore, x could equal -11, or x could equal 29. And those are your 2 solutions to that equation. You can try plugging them in to make sure they work. I'll leave that as an exercise for you, but it is good practice to always take your answers and plug them back into the initial equation to make sure they work. There is some Khan Academy practice listed in the description of this YouTube video. And if you're one of my students, the Khan Academy practice is also in Google Classroom. So good luck. I hope you enjoy completing the square, and I'll see you later.